Hey, good morning, everybody. We'll be getting started pretty soon. It's 10:57. We'll probably start around 11:01, 11:02. In the meantime, please look at the first slide up there. This is to basically ask any questions and see questions asked during this presentation. If you take a look at the top right hand of your screen, there is a question and answer section. If you click that, you'll be able to open up the dialog box where you can type. If you click your name, if you click anonymous, sorry, you can type your name so your name is displayed. There will be about a 20-second delay, so please be patient. And we'll get started soon. Hey, good morning, everybody. Welcome to the Miyano C-Axis Programming Review. This presentation will be given by Jinho Park, our Customer Support Group Manager. And Jinho, you have the floor.
Okay, good morning, everyone. This is Jinho, today's online programming review presenter. And today, I hope we're all gonna cover all the C-axis programming on Miyano machine. So on the Miyano C-axis programming format we will cover both the Fanuc and Mitsubishi control. In case of the Fanuc, I select the latest machine model BNJ51SY6, which has a OITF Fanuc control. And in case of the Mitsubishi control, I select the BNX51MSY with the M70 Mitsubishi control. Today's C-axis programming and format is basically your main turret and main spindle C-axis. That's what we're gonna talk about. So all C-axis Miyano machine involved with the cross drilling, which you're gonna use the X-axis live tool. And then next one is a face drilling. You're gonna use a Z-axis live tool. The same as a cross tapping X-axis live tool and face tapping Z-axis live tool, cross milling and face milling. Those are the one we're gonna talk about today. And any other C-axis application you can think of it, you can just click and question, and then we'll cover maybe after this session, or we're gonna make another schedule for those application programming. So first, we're gonna go on BNJ on Fanuc side first. The C-axis, I wanted to start with which way is a plus C-axis, which way is a minus C-axis. So if you look at from operator side, a main spindle, if it goes the spindle moves clockwise, that will be C plus. If the C-axis moves the counterclockwise, that's the minus direction. And then the BNJ, we're gonna use a machining data. So we're gonna use, you have to have a correct MC data. And then we will use a G500 because the main spindle side from the turret, we will use G511. So X drilling we will talk about. So first, other than the brown colored information, we're gonna have a 1, 2, 3, 4 line. Basically, it's gonna be all same format each tool. You will call tool number and the offset number, and then G511, you will positioning X-axis and C-axis and Y-axis and Z-axis, wherever you wanted to start the X-axis, the drilling. There's a two parameter. The first tool line, parameter number 5101, bit 2, equals 0 or equals 1, equals 0 if you turn it off. That's a high-speed X-axis drilling cycle, which means your drill goes down and retracts, not coming out of the part. It just retracts a little bit. Depends on your parameter number 5114. Let me go down to show you the parameter number. So 5101 bit 2, which calls RTR, that's the high speed or not. Right now, 0 means, let me go back. 0 is a high speed, which is not, your drill's not gonna come out of the part. it will just retract how much? 5114. This is all Fanuc parameter as a diameter. So 40,000 it will retract. So 20,000 per side. So that was the information. And there's another parameter. If you select the RTR as a 0, your tool will come out of the part all the way from the starting point, and it will coming back to rapidly parameter setting 5115. So you drill coming out of the part and retract approach again 50,000 away from the previous drilling point. So there's a 3 parameter involved: 5101, bit 2, and 5114 is a retract amount. 5115 is approach amount. It's all diameter. So let's go to the actual program. Of course, you need to rotate your spindle, in this case M43. And you, because of the live to work, you're gonna use a G98 feet per minute. So X drilling cycle is a G87. So first, X is your final dimension, how much you're gonna drill from 2.1. There's a G511, that's the approach. And then your final drill depth is X 1.0 as a diameter. The Q value in program, not like a parameter, in the program Q value is the radial value. So because of BNJ51SY6 has a 5 decimal point, unfortunately in Fanuc control, you cannot use a decimal point on Q and P. So you have to use, so in this case, 50,000 means 500,000 per side, radial value. So that's the packing amount. In this case, let me go a little bit more, H90. So your C-axis incremental value is 90 degrees. How many times is designated by the K? So twice. So you will, this program will drill first 90-degree index and drill the pack cycle to X dimension is a 1-inch diameter. And once it's done, it will index another 90-degree and do the second drill hole on the first line. And there is R value, R minus 0.05. That's the rapid approach from current position. Our current position at the G511, X 2.1. So 2-inch, 100,000 approach. And if we call R minus 0.05, this is also radial value. All Fanuc programming is pretty much radial value. So 2.1 and then minus 50,000 radius means 100,000 radius. So actually you're at this line, your x-axis will coming down to 2-inch diameter rapidly, and then start packing 500,000 per side, which means 1 inch per diameter. In this case, we are starting 2-inch diameter to 1-inch diameter, and because of the Q value is a ½ inch, so there's going to be no packing cycle. It will just straight down. And then I will go to the next line. It still be under G87 packing cycle. the C-axis will index the absolute 45-degree position. Now I changed the Q value 200,000. We didn't change the X value yet. It's still gonna go to 2 inch to 1 inch, but this time the Q is 200,000, diameter value 400,000. So you're gonna have a pack cycling about 3 times. So 200 each time, so 400,000 diameter smaller, and then it will coming back based on your parameter setting, and then couple packing going on the second line. And next line, another example, W means the Z-axis incremental value, 500,000. So it will move a Z-axis from current position to 500,000 plus, and still same amount of the packing, and it will do 4 times because there's a K4. And then I'm gonna move down to the next line. V is Y-axis incremental value. I didn't put the Q value here. I just take them out, the Q 200,000 and K 3 times. In this case, if you don't put the Q value, there's gonna be no packing cycle. It will just go straight in one drilling cycle. Of course, it will move the Y-axis incrementally 200,000, and it will do 3 times of the drilling cycle. So that's the example I have on X-axis drilling cycle. So once we understand this X-axis drilling cycle, the Z-axis is exactly same. So I will go to the Z drilling cycle, next page. The parameter we're gonna use the same as X drilling cycle parameter, which is a 5101. You wanna do your drill wanted to come out of the part, or just the backing up a little bit based on 2 different parameter setting. Instead of G87, now we're gonna use a G83, and the rest of the programming format is exactly same. One thing I wanted to cover of the R value on Fanuc control, the R minus 0.05 is a direction to the minus direction. Mitsubishi control, it really doesn't matter. You can put R plus or minus. Machine knows which direction to rapidly approach. Fanuc control, you have to designate the direction. So in this case, I wanted to go minus direction rapidly from current position to actual start drilling cycle. That's why I have a R minus here. And then exactly the same thing, you can do the few different packing cycle. It's still under G83 command. After the packing cycle, if you wanted to cancel the drilling cycle, you can go G80. Now, whatever the program you put it on will not be under the G83 drilling cycle. I want to stop right here and see if anybody has any questions here. Joe or Brian, is there any question?
So far, so good. Just want to confirm with everybody that you can hear Jinho. I got a question that some people, well, one person couldn't.
Okay,
Yep, so far so good.
So
that
if
makes
there's any,
sense. Oh, we can hear you. We think the one customer just had a problem.
I see. All right. I'm gonna move on the next programming CX's program. So next the line is the tapping cycle, live tool tapping cycle. I see a few of the customer has an issue with the tapping cycle programming. So XX tapping. So we got also a couple parameter, depends on you want to do the pectoral cycle or not. So same as a drilling cycle, it's a different parameter, 50 to 100 bit 5. So which designate the PCP, you go 0 or 1, makes high-speed packing or regular packing. High-speed packing means your tools, your taps, not gonna come out of the parts. It will stay inside of the part. It will just retract a little bit. Depends on parameter number 50 to 13. You designate a certain dimension here. Like I said before, Fanuc parameter dimension is always a diameter. So it's 100,000 means your tap will retract 50,000 per side. Or this high-speed parameter setting to 1, it will come out all the way out of the parts. The R I said over here is the R position, which is a original pectoral cycle start position. And 50 to 13 is retract value, so coming out and going in again. So first 3 line is always the same. Over here, it's a lot of customer. The third line had an issue. You program, but the PEC G88 cycle is doing nothing. So many case a customer or the programmer rotate the spindle. So any tapping cycle, the live tool tapping or even spindle tapping, we like to stop the spindle either M45 or in Mitsubishi control S3 equals 0. So we wanted to make sure your live tool stop or spindle stop before you go on in a tapping cycle. So that's where many program the machine tapping issue customer asking, So we need to stop the spindle, which is M45 to stop your live tool. And here's the format. And also many customer now, since we don't use a spindle, they use a G99 inches per rep, and then since the live tool involved, many programmer automatically thinking is a G98 inches per minute. And tapping cycle, that's not the case. So we're still gonna use a G99, even though we are not using a spindle encoder. So those two and tapping cycle program involved, those two are the important things you wanted to remember. And the next 3 lines from M66 and M92S spindle command, and in the Fanuc control you have to designate which spindle. P12 is a threaded 1 live tool spindle. You designate these 2, and X is a live tool tapping is a G88. And same as a drilling cycle, we need a final destination. And if you want to use a CAN cycle, H90, which is the C-axis rotate each time 90 degrees. How many times? As the K designate how many times you want to do it. It's twice I want to do it. R, same as a drilling cycle, minus direction. I wanted to approach to the close to the spindle, the part diameter, 50,000. In program, that's the radial value, not like a parameter as a diameter. How many, how much the packing cycle is always the Q is 20,000 means 200,000 per side, the radial value. So actually 400,000 on diameter. And then feed rate is whatever your pitch. And the next line without any command is a C45, which means still G88. X tapping cycle still control the next line. So your C-axis will go 45 degree absolute value. And then the packing 200,000. Just the one time over here. And next line, Z-axis incrementally 500,000 plus way, still packing, and then 4 times. In tapping cycle, the Q value goes into the memory. So the next line I tested with the V minus 200,000. Y-axis incrementally goes 200,000 minus direction and 3 times. I didn't put the Q value over here. But in this case, the Q value 200,000 in the memory of the G88 cycle. Without the Q, you don't have to duplicate. It's still gonna do the packing cycle over here, same as over here. That's the little different than drilling cycle. In drilling cycle, if you don't put the Q, no Q value at all, machine will not do the packing. But in tapping cycle, machines still remember as a packing cycle over here. If you don't want to do the next hole, tap hole, no packing, you can put Q0 value over here, next line. It will do just the one time no packing, no tapping cycle. So that's a little different than drilling cycle. I'm gonna go to the Z tapping cycle, pretty much the same as the X tapping cycle. We just need to change, instead of G88, we need to change to the G84. And then instead of M66, I put it on M67. Actually, in Miyano instruction manual, M67 is a left-hand tapping cycle. So why do but actually this one is for right-hand tapping. The reason, because Z live tool is a rotation direction is different than X live tool. We got one more gear, so we need to rotate the opposite direction. That's why the programming, even though I wanted to have a right-hand tap, I have to command the left-hand tapping M code because of simply the X live tool and Z live tool direction is opposite. The rest of them is all same. You just have to change the G88 to G84. There will be Z-axis, live tool, tapping, and Fanuc control. I want to go one more before asking a question. Since we're talking about the tapping cycle, I wanted to cover the spindle tapping cycle. This one is not live tool. This is a solid your stick tool tapping cycle. Same parameters, still controlling spindle tapping cycle. You want to do the PEX tapping or the straight tapping. We'll do exactly the same. And we don't want to rotate your spindle. We wanted to stop your spindle. And then the spindle tapping is M63. It's not M66 anymore because it's a spindle. And then same format, G84. We'll go with the packing cycle. Pretty much that's the all drilling and tapping live tool and also spindle tapping cycle. Think I covered that. And any questions so far?
So far, no questions right now. You're doing well.
Okay, thank you. Next, we're gonna go live tool, phase live tool milling, which they call polar interpolation. I should rotate this one 90 degrees. I think the next slide will show the 90 degrees. So I'm gonna set this 1 inch dimension. That will be the x-axis, and 1.6 dimension will be the z-axis. Let me go, and then I'll put the corner radius, quarter radius at each corner. So from the center point, so a polar interpolation, your program start from the center. So all the dimension from the center point. So polar interpolation and the Fanuc control, even Mitsubishi control, is a G12.1. And this example, so 1 inch, that's the x-axis, and 1.6, the horizontal is the z-axis I selected. So also we're gonna select a tool and G511, which we use MC data, automatically select the C-axis, C0, I put it on there. And once I get the, so on current position on G511, your tools will, let's say this is a 2-inch diameter, your tool is gonna be above of your part diameter. And your z-axis is 250 thousandths away, so we are safe, and we rotate your spindle. And we approach to wherever is a cutting position. Now we start G12.1, that's the polar interpolation G code. And we gotta designate the what plane we working on, because of there's G2, G3, those are the radius circular command need, machine needs to know which direction of which plane we are working on it. So that's the G17 we are working on, XY, but basically X and C is G12.1 is the one we're gonna work on. And we can use a G1, G41 to control if the dimension coming out a little bit big or a little bit small, then we can control with from the offset of the R radius designation. So on this program, the Fanuc control G12.1 is still x-axis a diameter value. From the center point, it's only 1/2 inch, but I have to program as a 1 inch as a diameter. And the C is 0. If we go X 1 inch, C 0 will be right here, right, this intersection. And now we move a C minus 55, which is, if you're looking at the face of the spindle, C goes counterclockwise. That's the minus direction. That's what we have. So your tool will travel this way. And next line, I got G2 because over here radius, and G2 is a clockwise, so it's a correct. G2 match the clockwise of the radius over here, and we gotta put the dimension of the x-axis, which is 250,000 from the center line, but we have to calculate as a diameter. That's why we have a x.5. And then Cx is dimension is the radial value. So 1.6 from as a dimension, but from the center line, it will be 800,000. That's what we have, a C minus 0.800,000. And we need to put the R radius, how much the radius value. This one is an example of easy to program, manually program. If these days, many of us using CAM software, they probably give you I and J, K kind of the value. But if you're doing the manually, I think just the simple R value is much easier calculate point to point. Once we understand the tool traveling up to here, the rest of them is just the point to point with G2 or G3 all the way around. That's what I have when in between G12.1 and all the way and G13.1. These are the polar coordinate interpolation using a CX as a program. And Fanuc control, I put it on here, a question mark. Once you go in polar interpolation or cylindrical interpolation, you cannot use a rapid command. G0, you will get the machine alarm, programming alarm. Machine will not allow G0 command inside of the G12.1. So if you wanted to move faster, you just have to change your feed rate much higher, so you don't waste your cycle time. And many times I get the question, so they pretty much wanted to have a flat along the side of the wall, but customer saying, I don't get the nice flat, I get convex or concave shape of the flat, which means your offset, basically geometry offset, your live tool center is not setting correctly. So example, if your center is above the center, you will have a convex shape. If your geometry offset is below the center somehow, you will have a concave shape. So you got to have this perfect center line, then you will have a nice flat along the wall side. And that's why we need to use G41, G42 to control this 1 inch or 1.6 dimension. So I guess customer or operator trying to adjust this 1 inch dimension is small, so they just offset it like a normal turning diameter offset it. So that's where it starts to showing convex shape or concave shape. All right, so any question about polar interpolation so far?
So far, so good.
Okay, I'm gonna move on. Next one. So let's say you want to do the thread mill on face. So here's the example from the center line, ½ inch away. So I'll say this one is x-axis. So you're programming the center point will be 1 inch. X will be 1 inch, which I have G511, X 1.0, C0. So you're facing thread mill will be the center of this hole. Of course, you're gonna rotate your spindle, and we start the G12.1 once we get in front of the hole. Same G17, we will use X and C. And then G1Z minus 0.5, that's the thread depth. I just go ½ inch inside of the hole. And from now on, I will say my tool major diameter, I still gotta go 100 thousandths to get the good thread height. So I wanted to move my tool going up 100,000 per side. So that's what I have, a G41U as an incremental 200,000 because I need to program as a diameter. And from that point, G3 is counterclockwise. And I go U minus 0.400, so which is from here all the way down bottom here. It's a half circle. I moved, and then the C-axis from start to end is the still same position. C is 0. Radius value is 100,000, so it will go around 180 degrees circle. Now I need to move because it's a thread mill, whatever the pitch, ½ inch 13, your pitch is a 0.07692 divided by 2 because I only moved a half circle here. That's what I have the first G3 line. From that point, I want to go another half circle, another half circle, another half circle. So basically that's the 2 circle of the thread mill. Each time I have to move incremental, the z-axis, half of the pitch. So you will get the right-hand thread. So this one is from inside to out. If you want to go outside to in, you need to change it. Instead of G3, you're going to go G2, and W will be minus direction. Okay, that's the polar interpolation with the C-axis involved helical thread mill program. I'm going to move on to the next one, still polar interpolation, same helical thread, but this time, since your machine has a y-axis, I don't use this example. It's not using G12.1. It's just a simple X and Y program, which is exactly same. Just instead of C, we will use a Y. Before I go cylindrical interpolation, any question on polar interpolation? Z-axis light to milling?
No questions so far.
If not, I'm gonna go, okay, let me go back.
I'll just tell you, Jinho, there is a lot of people there. They're not asking questions, so you're doing good.
I hope so. Okay. Polar interpolation. Let's say we did the face milling all the way around with this programming example, but I wanted to rotate this shape as a 45-degree angle, shaping, because I got another cross hole, the timing is different, so I need to move this shape 45 degree. What you can do, you can just simply go, here's, I don't know, you can see my cursor, there's a G0, C45. So your C-axis will move a 45 degree, and once you start G12.1 and the exact same program, you don't have to change anything. This shape of we're still gonna do same shape, but the C-axis is already 45 degree. Repositioned. So that's one way. That's the way you can do different location of the C-axis for polar interpolation. That's a little different than the cylindrical interpolation here. So exact same shape of the face milling, I put it on diameter. And this one, Fanuc control gives us a little bit hard time to, so it's not dimension anymore. We cannot use C minus 55,000, whatever. The C-axis is not a dimension anymore. We need to convert to the angle. Depends on your diameter. If your diameter is smaller, the same dimension, but it will be different angle, much bigger angle. So that's the trick of this G7.1 cylindrical interpolation program. So the beginning and all this one's the same. I will do, so when you get to the point, I start with a Z minus 0.2. Well, actually, this rectangle shape is right at the Z0 position. I think I programmed that way. Yeah, Z0. This line is a 0. So once you get the position, you program G07.1, C1.0. Now it tells the machine I'm working on cylindrical interpolation utilizing the C. So what is the C1.0? That's the whatever surface you're working on, divide by 2. So this is a 2-inch diameter part. I'm just work on the scratch on the diameter, this rectangle shape. That's why I have a C1.0, which means I'm working on 2-inch diameter part. After that, instead of G17, I need to change a different plane selection. So I'm gonna work on Z and C axis. Basically, Z and C should be G19, but in Fanuc control, they want us to use a G18 with which axis we're working on. So G18, I'm H0, which is a C axis I'm working on, and then W0, which is a Z axis I'm working on. So that's a little different than Mitsubishi. Mitsubishi will know whatever once you command special G12.1 command. So cylindrical interpolation, you need the G7.1 and the C diameter divided by 2, and then G18, H0, W0. Now machine will work on the cylindrical interpolation. So how to find the angle? So we need 1, 2, 3, 4, 5, 6, 7, 8 different position. Each location, the z-axis is a dimension, but the c-axis is a degree. We need to convert to the degree. So to do that, this diameter, the surface of the diameter or linear length of this diameter, we need to unwrap the CAM software talking, that's the terms they are using. Unwrap the diameter. We all know unwrap the diameter, the linear length of the diameter is pi times the diameter, which is, I just put it on here, pound 100, 2-inch diameter times a pi is 3.1.1592 will give us what 6.28 something. So right here we unwrap this circular length. And I put the pound 101 divided by pound 100 divided by 360. So once we unwrap the circular length, that's the 0 degree to 360 degree. That's why we divide by 360 degree. If you calculate that, these two, each 1 degree is a 0.01745 length. So I basically copied the polar interpolation program. So Z0C is a polar interpolation program. We start from the C0 and then C minus 0.5 and then C minus 0.8 on this dimension. So basically that's all same C dimension. I just add divide by pound 101, which we calculate before we even start here. That will give the angle. So based on this, the center line of the rectangle shape, square shape, center of this one is a C0. So from the 0 position to 0.55, the calculation will come up 30-some degrees and 40-some degrees over here. So automatically calculate all the way through until it canceled with the G7.1 C0 is a canceling of your cylindrical interpolation. So this example is from the tool point of the view. Basically, it's all top view. Your tool, your main spindle on the left-hand side, your tool comes in, your tool travel with counterclockwise this way. That's the example of this program. Okay, so now, once I made the part, I found out this is a wrong location. I need to move a 45 degree, plus or minus. This is a 45 degrees squid. So not like G12.1, if you just go locate the different C location, C45, what machine will do from the C45 all the way travel to this one. So you will have a big scratch line to this point. What I'm saying, just the relocation of the C location will not give you the whole thing as that much shift. So you need to move the C45. I still wanted to use the C45. And then next line, I will set the G50 C45 or something like that so we can shift. Otherwise, you need to change all this C dimension. We all good?
So far, all good, Jinho.
Okay. So very quiet, so I'm scared now. I'm gonna move on.
And this is the big difference to Mitsubishi, the C, where on Mitsubishi you can actually have a choice, C or
Right.
Y. And so,
Right, so
just got to make sure that the people listening understand this is very specific to Fanuc, and interesting way.
yeah, so that's I like on this G7.1. I like the Mitsubishi way much better. I don't need to calculate that much, but that will come up a little later. So I'm gonna move on to the next line. Now you want to do the thread mill with the OD. So we're not going to be able to use the C interpolation with the thread mill because it will give you the taper. So we got to use a y-axis, true y-axis program. One thing now we're not going to use any c-axis, so it's going to be Z and Y-axis program, so we need to select the plane selection as a G19 right here. And then you going in deep inside of the part. X 1 inch is a 2-inch diameter part. I go down to 1 inch, which means ½ inch per side. The programming wise is pretty simple. I'm just gonna move the y-axis 100,000 from that point, circling, same as the face milling, the halfway. So I gotta move the x-axis incrementally. So even though halfway, I gotta move the full pitch length because x-axis is diameter value. Okay, so that's the tooth circle of the right-hand thread from inside out. That's the example of the helical thread mill program. All right, so I'm gonna move on the Mitsubishi control side. Once you understand the Fanuc side, it's not much different. Mitsubishi side, X drill, different parameter. 8125. You wanna use a high-speed pack or you wanted to use a regular packing? So high-speed pack, your tool's not going to come out of the hole. It will just retract. Depends on retract amount on parameter 8026. And Mitsubishi control parameter is a radial value. So that's another difference. Fanuc side parameter is a diameter. Mitsubishi is a radial value. So it will retract 25,000 per side, and then drill again, retract 25,000, drill again. So that's the information on the first line with the parenthesis on. And other than that, we still use the G87, final destination, and then Mitsubishi control. Thanks to them, we can use a P and Q with the decimal point. So I put the Q.5, it's a radial value, and same as incremental, your C-axis will rotate 90 degrees each time. How many times? Twice, K2. And then R value, it doesn't have to be minus or plus. Machine just to know which direction to go. So Fanuc control, R value will like to put which direction you want to go, but the MITS control, it just to know where to go. So it doesn't matter. Mostly, I don't even command the R value. I just position right, in front of the hole. I don't even use a R value. I'll just drill. So if you don't command the R value, so wherever your starting position is the position that start the packing and coming out if you choose a regular packing.
Jinho, we
Yep.
have a question here. It says, can we go over what needs to happen when locating $2 C values after parting off if it is never right when it's set up without changing C values on $2?
Cutting up, it sounds more like a part transfer question.
Yeah, phasing, Jinho. So spindle phasing at cutoff. So part transfer, spindle phasing is basically the question.
Okay, so that's a Mitsubishi control or Fanuc control, two different way. Mitsubishi, we have a G9 890. That's how we do the spindle phasing. So spindle phasing is different than the sub-spindle C-axis position, if that's the question.
Yeah, so it's G899, correct, is the zero on Miyano. I'll add a little bit here. So if you run your part and you had it in a special location, if it was like milled and being picked up with an odd collet, or even a round part, if you bring the sub-spindle forward and clamp onto the bar in a setup mode, we can execute an M code, G899, that zaps that section as 0. So now C2 is zapped in as 0. Now when we go to use spindle synchronization and cut off, we have to use the proper code and syncing methods, and M203 is the spindle synchronization code, and a little argument R0. You got to make sure you have the R0. And then another way Jinho teaches a lot is to say C0 on $1 and C0 on $2, and then pick up the part and then turn on spindle synchronization. So you have multiple ways to do it, but you have to synchronize properly. Then when you go on the sub-spindle side, your C positions will be in a known place. I don't know if you want to add anything, Jinho. I kind of jumped in there.
Yeah, so G899, let's say you didn't mill the main spindle size. So let's say you have a hex material. That's not going to be the C0 on sub spindle, maybe not even C0 on the main spindle. It's going to be odd position. So that's where you wanted to use a G899R1 on your MDI. So the phase setting, whenever you command the M203R0, so main spindle and sub spindle is synchronized the same location. So your sub spindle can pick up your hex material. But that's not the C0. Your C0 is something else. It's just the phase setting. I'm not sure I give him correct answer, but
I think that's good. So if you have further questions, just email them in after the presentation.
okay, so I'm gonna go forward. So this example is all exactly same. If you command the Q value, it's a pack. If you don't command the Q value, there's no packing. It's just a straight drilling, one shot. I'm gonna go to the Z-axis, the drilling and MITS control.
We have another question here.
Okay.
H90 K2 makes sense, but they don't understand what the K4 and K3 arguments are controlling.
So since I have Z drilling, G83, H90 understand K value, K2? Is that the question? So K value is how many times you want to do. So twice. So on this line, because I already have a C0, G83, X, Z, and Q, H90. So first drilling cycle will not gonna drill the C0, will drill C90 because it's already moving this position. So C90 at this first time, the pack drilling cycle will be done on the C90 degree. One time, once it's done, and still this line, one more time, the C-axis move incrementally 90 degree. Now absolute value C 180 degree. It will do the exact same packing cycle one more time over here. That's the K value. We go further down. I have here, third line, I have a K4. Incremental value U 0.1, so your x-axis moving 100,000 minus direction on diameter, and then packing. And then one time is done, it will move another 100,000 and do the packing. And then the third time it will move 100,000 packing, and fourth time, that's what the K value. Fourth time it will do this command. Next line, 3 times because K say K is a 3. I hope that's the answer. I'm gonna move on. We're gonna go Mitsubishi Live Tool tapping cycle. Unfortunately, Mitsubishi Miyano live tapping cycle, there's no pack tapping cycle. It will just do the one shot tapping. So G88, it's all same. Oh, I gotta explain a little bit different. Okay. So G97, we talked about, we like to stop the spindle. MITS control, we can stop the spindle as S3 equals 0, or M45 still gonna work. And we need the G99. It's not inches per minute. And G88 is an X tapping cycle. X 1 inch, that's the final destination. Incremental value 90 degree. Even though we start with the C0, the tap cycle will start with the C90 because H90 here. And we'll do one more time. K value is 2. R 0.05, it will rapid approach 50,000 closer to the material. And feed rate is your pitch. D3 is your live tool. D1 is a main spindle. D2 is a sub spindle. D3 is your turret spindle, which is a live tool. Spindle 250 RPM. comma R1 is a synchronized tap, so you can tap again later on if you wanted to. We'll do twice over here. But there's a no queue, none like a Fanuc control, we cannot do the pack cycle. Next line, because we start with the C90 and 180, I'm gonna go to C0 and W.2. Z-axis incrementally move the 200,000, do the tapping cycle, and then one time is done, C is still 0, it will move the Z-axis 200,000 further out one more time and do the tapping cycle. That's the two line of the tap cycle. So X-axis is the tapping cycle. Okay, I'm gonna go Z-axis live tool tapping cycle. Same command as instead of G88, we need to use a G84. All same, but now it's still D3, but because of the live tool mechanism, we need to make a D-3, which is a left-hand tapping, but the live tool is one more gear, it's still gonna make a right-hand tapping. So you need to be careful if you don't want to break your tab at the first time. And if you break your tab the second time, that's something wrong then. So that's the Z live tool tapping cycle. Want to cover spindle static tool holder tapping cycle. We wanted to stop the spindle.
Question real quick.
Okay.
On the G88, is it possible to add a second G88 below it, or
Sure.
even a third to split the depths on the tab?
Let me. I gotta get out of this slide show. How I'm gonna do right here so he can see. How can I? I'm way out of it. X tapping right here. Can you still see the screen?
Right now, no. So you have to say share that screen again.
Oh, okay. So I cannot type in anything. Okay, I'll just do this one. G88 X 1.5 C0.
Well, Jinho, the question for PEC tapping, don't we just have to add an XXX after the G88?
Yeah, that's what I'm doing.
Okay. Okay.
Okay, so
So your screen is still not shared, just so you know.
yeah, I hope I don't messing up this one. Slideshow from current site. Now I gotta share. Oop, how to share? Share. And this one. Can you see?
Yep, you're live again.
So this is not like a slideshow, it's just the one page, right?
Correct.
Okay, so this one, you got this one. I'm gonna go, okay. Here, I just add this 3-line, another G88. So X 1.5, C, I need to put the feed rate over here and D3, so all rest of them from F DS, R1 on the second line, I believe. We'll do the X1.5, the tapping, and then go to the next line. Still under G88, it will go X1.2. It's kind of manual, packing cycle, a little bit deeper and a little bit deeper over here. Still under G88. Is that the answer? I'll just leave it like this.
Yeah, I think you have, yes. So yes, we can pec tap. And yes, there's another added in question. Will it recapture the lead? And yes, it will. And then there is one more question on the tapping. In order to reduce cycle time, is it possible to increase RPM on the pullout?
I believe that's an option. The Q3000 or something, right? The 3 times. Yeah.
Correct. It's a light option. It's called high-speed tapping. I don't, here we're quoting, I don't want to quote a number, but it's something like $500. I don't remember, but it is a small option for high-speed tapping on a Mitsubishi. On the Fanuc, Jinho, do you remember?
No, I don't see that option on the Fanuc.
Okay, please continue.
Okay, so now we're moving on the spindle tapping. The important thing is we need to stop the spindle. Lots of programming rotate the spindle before start the G84. So stop the spindle and we'll give you less headache. And G84, now we are doing spindle 1. That's why I have a D1 here. And that's about the drilling cycle and tapping cycle. I think I'm stretching a little bit too long now. It's about already. We're almost done. So I will move on to same polar interpolation on Mitsubishi control. Pretty much same thing. Our Mitsubishi control, you have a choice. G12.1 D1 E equals C or G12.1 D0 E equals C. If you select the D0, your programming is a Y-axis. If you choose the D1, is the C programming inside of the G12.1. That's the difference. Another difference on the Mitsubishi, the X-axis is not diameter anymore. It's a radial value. So it's just like your milling program, machining center program, you can import and you pretty much can run. You don't have to double up on your X dimension. Another one, a Mitsubishi control different, you can use a Z rapid command. You're not gonna get the alarm, machine will take it. Control
you have a
will
little
take
bit of a problem is not everybody seeing your screen like the screen. We're seeing your mouse move. So can you run your presentation, please? So, or are you running your presentation?
Yes,
I think you just have to.
You have to
slideshow.
unshare and share again the screen like we did the first time.
Screen. I think I'm sharing now. Can I see my screen?
We see your development PowerPoint, not your running PowerPoint.
Huh?
So unshare and share again with screen 1.
Stop sharing and share. Something being shared. Okay, is the sharing? Which one? Slideshow.
Now we got something.
Okay, so
back up and then continue where you were there. So
okay,
right in here.
all right. So I was here.
Okay, thank you.
Okay, so G12.1 D1 E equals C and Mitsubishi control, we have option to program C axis or Y axis inside of the G12.1 and between G13.1. The differences we talked about, the X axis here is a radial value, not the diameter value. That's the difference between MITS and Fanuc control. And then MITS control, we can use G0 for rapid movement between inside of the G12.1, which Fanuc will give you an alarm. That's what we talked about. So I'm gonna move on the next slide. Polar interpolation. I think it's a pretty much the same programming. You just have to be careful. I just copy and paste and change the U value because now it's radial value. Fanuc control, the G41 U.1, it should be U.2 because Fanuc is the diameter. And even the location, the after G17 here, I programmed X.5 from the center to the center of the helical thread, 0.5. It's not 1 inch anymore. So that's the difference between MITS and Fanuc control. I'm gonna move on. So Y-axis of programming is, yeah. So now because of we are not using G12.1, the U value has to be diameter value and then circling. So this is the example of the thread mill using Y-axis. I'm gonna go. Okay, so the Fanuc control, we do the cylindrical interpolation with the G7.1. Mitsubishi control, we don't have a G7.1, we do have a G16 and the C, so same as a G7.1, but we use a G16 under inside of the G12.1. And then again, the X is not the diameter anymore, it's a radial value. So pretty much in all the geometry, you're not gonna use a X unless you just digging in from beginning, you know, the depth of your final dimension of the X-axis, but still it's gonna be radial value. And one thing I found out between Fanuc and Mitsubishi cylindrical interpolation, the corner, the radius, Mitsubishi is correct, the G3, the counter. So because of my tool moving along this way, if you're looking at from the tool point of view, this is a counterclockwise. Somehow Fanuc control gives the G2. This one, Mitsubishi, is a G3 on this corner. That's the one more difference between Mitsubishi Fanuc control. Other than that, I am pretty much done on this cylindrical. And the last one, Y-axis helical thread mill, most of the time you wanted to use. I gotta remember we need to have a G19, and the programming wise, pretty simple. It's just I'm doing a half circle each line, and you gotta move the X-axis according to the whatever the thread pitch. I think I'm done for CX's work on Mitsubishi and Fanuc control. Any questions? And I'm pretty sure that Joe, you made this one the record, and any of you wanted to have a copy of this slide, I will send this slide to Joe, and then he can distribute to whoever wanted to have it as a sample.
Yep, that's right. So far there's no questions, but I'll give it another minute or two if anybody else has any other questions.
And then one more, you can put it on your questions. So is there any other, programming session and topic you want us to cover maybe next week or whatever, month later? Give us a suggestion. We will consider, we will prepare. If it's a good one, then we'll do that too.
Yeah, so if you're a dealer or a customer, we welcome your ideas of a web event. If it's a cutting topic, and I'm making it up, Polygon, or if thread milling, if something was more in detail. But there's a specific topic that you think you would like trained on, we would like to consider it in our future training. So please just let us know.
Well, so there doesn't seem to be any more questions. That basically wraps up the Miyano C-Axis program review. Thank you, Jinho. And
thank you, Joe.
Thank you, everyone who attended. Have a good day.
Right, thanks. Okay, bye.
Thanks, Jinho.
Thank you.